Hello, young math Padawans. It's Mrs. Angel with a quick video on ratios. So let's start with the leading question. What is a ratio? A ratio is a comparison of two quantities, or sometimes we say how two quantities are related to each other. Now, a ratio can be represented in three different ways. We can represent ratios as fractions. This could be like quantity A compared to quantity B. Using a colon, quantity A to quantity B, or using the word to, quantity A to quantity B. So in order to create ratio, first we have to have some quantities to compare. So that brings us to our first example here. Dog tags at Petco come in three different shapes: circles, bones, and stars. The bin at the cash register contains the tags shown below. Here's our circles. Here's our bones. Here's our stars. All right, so our directions say to first identify each ratio as part to part or part to whole. Well, what does that mean? Well, whenever you have different quantities, sometimes those quantities will represent part of the total, and sometimes they'll represent the whole total. In this case, our parts would be the number of circle tags, the number of tags that are bones, and the number of tags that are stars. But then what would our wholes represent? That would be the number of total tags in the bin. Okay, then after we identify that, we have to write each ratio in three forms: as a fraction with the colon and using the word to. Then we're going to write an equivalent ratio using the fraction form and the given factor of 1. So our first example here, we're asked to compare the number of circles to the number of bones. Well, let's go figure out how many circles we have. I count 1, 2, 3, 4, 5, 6. 6 circles. And how many bones? 1, 2, 3, 4, 5, 6, 7, 8 bones. I'm going to write that number next to bones. So this ratio is what we call part to part because we're comparing part of the total to another part of the total. So let's start with writing this as a fraction. Circles to bones as a fraction would be the fraction 6 to 8. Circles are numerator, bones are denominator. We always read from left to right and top to bottom. Using a colon would be the same thing. 6 to 8. We always read from left to right and top to bottom. And using the word to, circles to bones, 6 to 8. Simple enough. Now an equivalent ratio with the given factor, but I haven't given you one yet. So I'm feeling like 5 today. What this means is if there were 5 times as many circles, for this ratio to be equivalent, there would also have to be 5 times as many bones. And for that matter, 5 times as many stars and total tags. So the way that we do this is we're going to take the fraction form of our ratio, 6 to 8, and we're going to multiply it by this factor, 5/5, this big 1 factor. And that's going to give us an equivalent ratio for what if there were 5 times as many of these. So 6 times 5 is 30, 8 times 5 is 40. So if there were 5 times as many circles and bones, to keep an equivalent ratio, there would have to be 30 circles and 40 bones. Simple enough. Why don't you try number 1 on your own? First, let's count the total number of stars. I count 7, and we already know that there are 8 bone tags. What type of ratio is this? Part to part. As a fraction, 7 to 8. Using a colon, 7 to 8, and the word to, 7 to 8. Now, what happens if there are 3 times as many stars? There'd have to be 3 times as many bones. So we multiply 3/3 by our fraction 7 to 8, and we get 21 to 24. That would be the equivalent ratio if we had 3 times as many of both. Number 2, the number of circles to the total tags. Well, we already know there's 6 circles, but how many total tags are there? Let's quickly count.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21 total tags.
Now circles, that's part of the total, but total tags represents the whole. So this would be an example of a part to whole ratio. Now fill in the rest. As a fraction, this would be 6 to 21. Using a colon, 6 to 21. And the word 2, you guessed it, 6 to 21. Now, what if there were 10 times as many circles? Well, there would have to be 10 times as many tags. So we take our 10/10 and multiply it by our fraction. 6 to 21. Simplify that. 10 times 6 is 60. 10 times 21, 210. All right, why don't you go ahead now and try numbers 3 and 4 on your own? Let's see how you did. 7 stars to 21 tags would be a part-to-whole relationship. Here are our 3 ratios, and an equivalent ratio would be 28 to 84. Bones to total tags would be 8 to 21, another part-to-whole relationship. Here are our ratios, and our equivalent ratio of 40 to 105. Last example here. This one's kind of weird. Circles and bones compared to the number of stars. Let me look at the picture again. Okay, so it wants us to total up the number of circles and the number of bones and compare it to the number of stars. Since we're still only talking about circles, bones, and stars, and nowhere do we talk about total, this is still a part-to-part ratio. All right, well, we know that there are 6 circles and 8 bones. So if we added those together, because the word and usually means add, that would be a number 14. And then how many stars were there? Oh yeah, 7. So the ratio of circles and bones to stars would be the ratio of 14 to 7. 14 to 7, 14 to 7. Now, if there were twice as many circle and bones, there would have to be twice as many stars to keep this ratio equivalent. So that would be 28 to 14. All right, young Padawans, you know what happens next. Go ahead and do number 6 on your own. How'd you do? Well, we know that circles and bones combined is 14, and there are 21 total tags. And because we're comparing circles and bones to the total tags, this is a part-to-whole ratio. There's our fraction, 14 to 21, our colon, 14 to 21, and the word 2, 14 to 21. If there were 6 as many circle and bones, there'd have to be 6 as many total tags, and we have an equivalent ratio of 84 to 126. So a ratio is a comparison of 2 quantities. We have our fraction, our colon, and the word 2. We made some equivalent ratios, and we identified part-to-part versus part-to-whole. So that's it for today's lesson. I'll see you next time.